All right, hello everyone. So this is a video for my Biology 121 class where we missed a lab, so this is the makeup PowerPoint for that. So what I'm going to do is walk you through the bones on the list that you need to know, and the ones I show you will correspond to the ones that we end up quizzing you on D2L. So let's get started. So here we have the sacrum, and the sacrum is the end, the lower end of the spinal column. So here we can see some, let's draw an arrow, lumbar vertebrae. And at the end, there's this weird flangey thing. It kind of looks like a cockle shell. And this is actually a structure that's made out of 5 fused vertebrae. So when you were a baby, these were separate. And then as you made your way toward adulthood, these bones gradually fuse into one solid object. So that's why it looks the way it does. It's kind of weird, but it's also what allows it to articulate with the lumbar spine. So you can see that the leftovers of the intervertebral foramina are still observable on the sacrum. And your sacral nerves come through here. So the nerves of the sacral plexus are what come through here. So that's why this bone looks like it does. So it's 5 fused lumbar vertebrae. Now let's turn this around. This is the anterior view, by the way. So in the next slide, posterior view, now we have an actual human sacrum and coccyx, which you can see in a little bit more detail. So this, again, is the sacrum. And this little guy down here is the coccyx, aka your tailbone. So it's also some fused vertebrae, but they are extremely rudimentary and have secondarily lost almost all of their familiar features. So no vertebral body, very little in the way of transverse processes, no spinous process at all. So it's basically just a little bony nubbin. So that's this little guy right here. Now we're moving all the way back up to the top. This is the hyoid bone. So the hyoid bone sits right above your thyroid cartilage. So this is your voice box. And your hyoid bone is right above that. So it looks kind of like a little tiny vampire mandible. So it's got a body and 2 horns, and the lesser horns poke upward like little pointy teeth. So this thing is going to be the insertion point for a bunch of different muscles, and if you feel your throat, if you put your hand on the front of your throat and do a nice big gulp type swallow, you can feel your hyoid bone tip up and then back down during the swallowing motion. So it's critical for changing the way your pharynx is shaped during swallowing. So that's why we learn it, and that's why it's important. Moving on down to the sternum, this is your breastbone, so it's right in the center of your chest, and your ribs articulate with this to give your thorax a nice sturdy cage shape. So in infancy, the sternum is actually 3 separate bones, and then they eventually fuse, much like the epiphyseal plate closes in a long bone. So the top part is called the manubrium, and manubrium is Latin for shield, like the kind you would hold during battle. So that's what that means. The body is the longest part, and that's just the body, so no special Latin name for that. And then at the very end, there is a pointy bit of bone called the xiphoid process. And the xiphoid process is used to find the appropriate compression position in CPR. So you put your fingers on the xiphoid and then you go 4 finger lengths up so that you're applying compressions to the middle of the body of the sternum. One of the common injuries that happens during CPR is that people applying compressions in the incorrect spot will end up breaking the xiphoid process. But if you have a choice between being resuscitated and having a broken xiphoid or not being resuscitated, I would bet that your preference would be resuscitation. So, oh well. Okay, so having mentioned the sternum, let's talk about the ribs. And ribs come in a couple different varieties. So ribs 1 through 7 are true ribs, and then the rest of the ribs are false, and in some cases floating. So let's go over what the distinction is. So here we have the manubrium of the sternum. Here's the body. Here's the xiphoid process. And then this white part right here, that is called the costal cartilage. Not coastal, but costal. So the costal cartilage is the cartilage that allows the rib to articulate with the sternum. So costal means of or related to the rib. Now, all of the true ribs have their own costal cartilage. So if I trace with my pen the connection between the rib and the sternum, this one has its own costal cartilage, this one has its own, this one has its own, this one has its own, even though it's stuck to its neighbor. And so does this. The vertebrochondral ribs have costal cartilages that are stuck to their upstairs neighbor instead of having their own direct line to the sternum. And then these last three, one of which you can't see, are floating ribs. And those don't have any connection to the sternum at all. So if on a rib cage I point at, say, this rib and I ask you to identify the bone, you need to come up with rib A. And if I ask you what type, you need to say true or vertebrosternal. Okay, the scapula. So we already have a couple different views of the scapula. The scapula is your shoulder blade. So let's start with the center view actually. So this flat thing is actually a little bit of a dent, and that's called the glenoid cavity or glenoid fossa. So remember, a fossa is a depression in a bone. This is the depression in your scapula where your humerus, your upper arm bone, articulates. So this forms your glenohumeral joint, which is where your arm meets your body. So this is the anterior view of the scapula. So if you're looking through the rib cage to the side of the scapula that faces front, here we go. And a couple of things to note. Here we have the coracoid process. Now, coracoid means crow-like, or looks like the beak of a crow. So if you imaginarily trace this out, this little process does indeed resemble the head of a crow. Let's give him a little face. So that's what coracoid process means. The one on the other side of the glenoid cavity is called the acromion, and this acro means high up. So this is the tallest process on the scapula. The acromion is actually the end of a long ridge of bone called the scapular spine, which is right there. And the reason for these is there's a bunch of ligaments that run between these two processes and your humerus to help stabilize your shoulder joint so you're not constantly dislocating your shoulder. So the fossa above the spine is called the supraspinous fossa, and the fossa below the spine, which is much bigger, is called the infraspinous fossa. And the bony part on the fossa is on is the body. Okay, humerus. So this is your upper arm bone. It articulates with your scapula at the glenoid cavity. And remember from lecture we talked about Wolff's law, which states that bones are going to be thickest in the locations where they're most likely to buckle. You can actually see that that's true for the humerus. So this thick area also includes the deltoid tuberosity. A tuberosity is a raised rough patch, and this is the spot on your humerus where your deltoid muscle, which you just learned in lab, inserts. So if you put your hand on that spot right about in the middle on the lateral surface of your humerus and flex your deltoid, you can actually feel it. If you follow the deltoid tuberosity up, you're going to land in a dent right here, and that's called the intertubercular groove or sulcus. And intertubercular means between two tubercles, and indeed it is. So here we have the greater tubercle and the lesser tubercle. So you might be wondering, how can I tell these apart? Well, the greater tubercle is larger in surface area and higher up on the humerus itself. So it's closer to the very top than the lesser tubercle is. The lesser tubercle is smaller and it's lower down. And the intertubercular groove runs between the two. Now, you can see the head here which is divided from the rest of the bone by what's called the anatomical neck. And that's the anatomical neck refers to the place where the epiphyseal line would be found. So the proper anatomical division between the epiphysis and the diaphysis. The surgical neck is this narrowing. The surgical neck of this bone is named because this is the place where it usually breaks. So not at the anatomical neck, but rather at the surgical neck because this area has less structural integrity. Now if you go down here towards the distal end, remember distal means further away from the point of attachment, so in this case distal would be away from the armpit. We've got this bizarre condyle. So this is one condyle and it's divided into the capitulum, which means head, and the trochlea, which means pulley. So these two things articulate with the radius and the ulna, respectively. And we have two fossae here. So on the front of the humerus, there's a small triangular dent called the coronoid fossa. And on the back, there is a large, deep triangular dent, and that is the olecranon fossa. And those two fossae correspond with some particular structures on the radius and ulna, which we will see next. Okay, here's the radius and the ulna. In this case, the interosseous membrane has been left intact. This is a web-like ligament that stabilizes the relationship between the radius and the ulna. So here's the anterior view, and here's the posterior view. So the radius has a very circular head and a wide, broad distal end with a little point on it, and that's called the styloid process. Styloid means pen-like. The ulna has this very prominent U-shaped or cup-shaped proximal end, and that is one way you can try and remember it. So ulna, U for ulna, this is a sideways U. So the olecranon is the top part of the ulna, and that articulates with the olecranon fossa of the humerus. The other side of the notch is the coronoid process, so just right there and just right here, and that articulates when your elbow is bent with the coronoid fossa of the humerus. So that's why those things are named that. On the side, there's also a radial notch, which is a little divot that accommodates the head of the radius. So you need to be able to tell me which one is the radius and which one is the ulna. Oh, also, the ulna has a styloid process of its own, so it's not good enough on the quiz just to say styloid process. You have to say that it's the styloid process of the radius or the ulna. So you have to tell me which bone it's on too. Okay, so now let's look at the bones of the hand. And the bones of the hand include your carpals. Let me get my pen. So your carpals are an association of little, assortment rather, of little pebble-like bones that make up your wrist. So carpals. And in 231, you do have to know the names of all of these. So there's like the scaphoid and the pisiform, which is right here, for example, but we're not going to make you know them. Just know that they are the carpals total. These long guys, which I'm going to outline with my pen here, these are the metacarpals. So these make up the bones of your palm and the base of your thumb. So that's your metacarpals. Now let's talk about finger bones. So in the fingers that aren't the thumb, you have 3 phalanges. So singular of that word is phalanx, plural, phalanges. You have phalanges in both your hands and your toes. So your fingers and toes are analogous structures to each other. We have just specialized our lower phalanges for walking upright instead of crawling around. So this is the proximal phalanx. Oops, that should be an X. And this one is the middle phalanx, and then the tip is the distal phalanx. My pen won't let me write an X. There we go. So every finger has a proximal, middle, and distal phalanx. Your thumb only has a proximal and a distal one, so there's no middle. So you don't have those 1, 2, 3 joints in your thumb, you only have 2. All right, so that's hand stuff. Moving on, let's talk about the pelvic girdle. So the pelvic girdle is made up of your 2 hip bones and your sacrum. So you have one os coxa and another one. And I'm going to actually do a little nitpicky thing. So this is a PowerPoint that I borrowed from a colleague, and this should properly be ossa coxae. So that's plural. And the singular is os coxa. So that's the name for one of these bones. So singular is this one only, not both of them. You may also see these referred to as innominate bones. So that's another acceptable term for them that you could put. And the ossa coxae, like a lot of other bones in your body, used to be not fused. So they used to be 3 separate bones. So the part that makes up what we classically think of as our hip bones, these are our ilia. So ilium is the top part that I'm circling here. The pubic bone is the angular portion at the front. And the 2 pubic bones meet up in the middle, and they articulate via a fibrocartilage disc, and this joint is called the pubic symphysis. And then your sit bones, so the bones that make contact with your chair when you sit down, those are your ischia. So ischium is one of those. So each os coxa consists of an ilium, an ischium, and a pubis. Okay, moving on to the femur. The femur is your thigh bone, so it's the largest long bone in your body. The head of the femur fits into a structure on the os coxa called the acetabulum, or acetabulum if you're a fancy British guy. I don't really care how you say it as long as you can spell it, mostly correct. The femoral head fits into there, so that's your hip socket and hip joint. Again, we have a surgical neck versus an anatomical neck. So on the femur, the anatomical neck is where the femoral head ends, and the surgical neck is this broadened, more neck-like looking thing. And there are 2 features on the femur that are specific to the femur. So this large bump here and this smaller bump here, these are called the lesser and greater trochanter. And you don't find a trochanter on any other bone in the body. It's a bone that is, or a feature that is only found on the femur, and it has to do with walking upright. Down here we have the condyle, so this is the lateral condyle and this is the medial condyle, and then there's a smooth triangular patch of bone on the front, and that's the patellar surface, so that's where your kneecap articulates. And then the femur has a nice long diaphysis, which is broadest in the middle, as per Wolff's law. Okay, so speaking of the patella, let's check that out. So the patella is a sesamoid bone, named because it looks like a sesame seed, just a real big one. So this is the anterior view of the patella, and you can see that it's fairly rough. It sits in the patellar ligament and help stabilize your knee joint. So the pointiest part, or the apex, faces downward, so down towards your foot, and then this is the top here. The patellar surface on the femur articulates with the articular surfaces of the patella, and the lateral articular surface is much broader, so I'm going to outline that with like a dotted line. So this is a broad, shallow depression. That's the lateral articular surface, and this is the medial articular surface. So you can see 2 broad, flat areas here. All right, the tibia and the fibula. And I want to warn you about a spelling problem, because normally in 121 we don't count spelling super hard unless you screw up the word so badly that I can't tell what you're saying. But for these 2, since they sound so similar, if you spell it like this, tibula, that's literally 50% one word and 50% the other word, and I cannot tell what you mean, and I cannot say for certain that you can tell the difference between the two bones, so you get no credit for that. Same deal with fibia. Also, we've all taken true and false tests in elementary school, so if you ever encounter this in a written form where you have to spell it out, doing this thing where you make it sort of intermediate between a T and an F is a trick that all teachers are aware of, and it's never acceptable, so don't try it. I've seen it done before, and it makes me chuckle every time, but none of that. So just be careful when you talk about these two bones, because the more times you say it incorrectly, the more times your brain will decide to reinforce the incorrect memory. So tibia is the bigger one, and if it helps you, you can think tibia equals taller. So this is your shin bone. You can actually feel it on yourself. And your tibia is medial, and it culminates in this structure here, which is the medial malleolus. And your medial malleolus you can feel on yourself. It's the inside ankle bump on the bottom of your leg. Your fibula is much skinnier, which means it tends to break more often than the tibia, so you can think fibula equals fragile. That's a good way to distinguish the two of them. And this is a long, spindly bone, and it culminates in another malleolus, and that one is the lateral malleolus. So tibia has medial malleolus, fibula has lateral malleolus. So that's the tibia and the fibula. Now we have to go down and do some foot stuff, and then that will be the end of the PowerPoint. So here we have the bones of the foot, and you can see, oops, I want the pen, there we go. So here we have the medial malleolus of the tibia, and the lateral malleolus of the fibula, and they are sitting on top of a bone called the talus. Now, the only one that actually puts weight on the talus is the tibia, so this is forces of gravity. The fibula just sort of plugs into the side. So this is your talus, and here it is from the side. So this is the one that bears all of your body weight. Now you can't see the calcaneus from this anterior view, but you sure can from the side. So there's this big bone called the calcaneus, and that forms your heel bone. You must put calcaneus on a test. You cannot put heel bone. We are here to learn anatomical terms, not colloquial common parlance terms for bones, so make sure you're putting calcaneus. All right, so similar to the hand, we have a collection of small sort of cubical bones, and we're not going to make you memorize cuboid versus navicular, etc., but instead just know that these are the tarsals, and the talus and the calcaneus are actually specialized tarsals as well. But they're two that we need you to know specifically because they have such a big role in walking. Okay, so similar to the hand, we've got the same scheme going on. The tarsals connect to the metatarsals, which make up the most of your foot, so the meat of your foot. Then, all of your toes that are not your big toe have a proximal, middle, and distal phalanx. So each of these is one of your toe phalanges. And then your big toe only has a distal and a proximal one. And your big toe has a special job. It has a lot of muscles that are devoted only to the big toe. We didn't learn them in 121, but you will later if you move on to 231. Your big toe is heavily involved in helping you balance when you're walking upright. So next time you're standing in line, minding your own business, just be mindful of your feet and the way that you shift your weight. And I think you'll find that if you didn't have a big toe, you'd have a lot harder of a time standing up and standing still. So your first metatarsal and your proximal and distal phalanx are really critical for balancing on our human feet. All right, so that's the end of this PowerPoint. I'm going to post it on YouTube now and give you guys a link, and you can watch it as many times as you want. And then next thing I'm going to do is make that virtual quiz for you to take. So you'll have one attempt on that quiz, so make sure that you make it count. But of course, since it's happening at home, it's open notes and open book. So you can even have the PowerPoint that I'm showing you now running while you take it. So I wish you the best of luck, and I will see you guys next Saturday. Bye.